I wanted to take a minute or two to go through the Pascal's line for a four-pointed hexagon. Remember, hexagon normally is 6 points, but this is 4 points. But before I do that, I wanted to say a little bit about projective geometry and why it's useful, and some of the typical problems I see in some of the drawings that I think if you corrected, you'll get the satisfaction of getting the drawing that's showing what you want it to show. Excuse me. And you get the satisfaction of having a nice, accurate drawing to refer to. But why am I even having you do this? One way to think about it is, I like to think about it kind of as a recipe, if you've ever cooked or made some food. Some recipes are actually really particular. You have to do things in a certain order, in a certain way, or else your result just won't come out right. And some things, the kind of things I make, that's probably not the case for. You can mix things together in different orders and do different things, and you'll get something close enough that it's still good. But there are recipes that are pretty particular. You got to cook it at a certain temperature, maybe certain types of candy, certain types of cakes, souffles. There's a certain way it has to be done, or else the result will not be what you want. Think about this like that. And that is a system, by the way. It's a really particular system. Everything has to be done just right to get what you want. The same is true here. And what I appreciate is if you're not getting what you want, I know a couple of you have actually said, this doesn't look right. Something's wrong here. I'm not sure what it is. That's good. That tells me that you're looking at it and saying, okay, something's not right. I probably need to fix something. And I can help you with that. I can help you fix it. And I'd like to, so that you can get the satisfaction of doing it and getting the system output the way it's supposed to be for this projective geometry, which is why I'm having you do it, is so that you can actually follow through with the rules as they're supposed to get the outcome that is intended. So with that in mind, try this one, and if you get stuck, talk to me. Or if you're confused about it, let me know, and I can work with you. And this is true for the remainder of the semester as well, on any of these. So we're going to start with 4 points on a circle. Now the first thing you're going to do is you're going to connect all of the points. And so this point here would be connected to there, this one here connected to there, this one here connected to there, and then that one connected to there. The problem is that's just a quadrilateral. So then I actually have to pick 2 other points that are the sides that kind of decayed into a point. And so for both of those points, I'm going to draw a tangent line. I happen to pick the points down here that are those decayed sides. So I'm going to show you on the next slide here, and I put a little heart by each of those. There's my quadrilateral. Looks kind of like a trapezoid, if you remember your shapes. It looks like that. But on this point here, one of the sides is there. That's the missing side that happened when the 2 points that used to be here came together to be one. The same thing's true over here. I didn't draw that one yet. But the same thing will be true over here. There has to be another line that tangent to that point right there. I draw that on the next slide. There we go. And then I have to number them. One of the problems I often saw in many of the diagrams I saw, one problem is that people didn't always use a good circle. You can't just draw it by hand. You really need a lid or a compass, or if you do it online on a Microsoft Word or PowerPoint or some application where you can draw a clean circle. It has to have a clean circle, and the lines have to be straight lines, and the points have to be right on the circle. So in this case here then, the other thing you have to do is you have to make sure you number the lines correctly. On a lot of the ones I'm seeing, number 2 may not be next to number 1, or they may not all be numbered. So it makes it really hard to track which lines are associated with which numbers on the circle. So make sure you number them consecutively. So I go 1, 2 in this case, and then when I hit the tangent line, that has to be 3. It has to be between the 2 other lines that are going through that point. So 3 is here, and then let's see. 3 is the tangent line, then 4 is the next line that goes through that same point there. Then when it hits that final point, the 4th point, line 6 is the one that's going to come out from it, and the tangent to it is going to have to be line 5. Again, then you have to take lines 2 and 5, 3 and 6, see 3 is here, 6 is there, and 1 and 4. And connect them all, and make sure you extend the line enough so that they intersect, so you can connect them at the proper point. And if you do that, on the next slide you can see it, there's 3 and 6, 2 and 5, 1 and 4. If you don't use the right lines and connect the right lines, you will not get a line. You will not get Pascal's line. You have to use the right line, the proper lines to do this. But if you find them and correctly, you will get this to work if you do all the steps correctly and locate your lines, make sure the points are directly on the circle, number the lines consecutively. You will get the outcome that you seek. All right, good luck with that.